Calculus Nerd 23 here. We got a tight new unboxing of a killer product. Should be at the doorstep. Let's go see.
Let's go check it out.
Yep. Oh, tight. It's right here.
Sweet.
Yeah. Meet you back in the room. We'll do a quick unboxing of this bad boy. We got the product right here. We're about to unbox it. It's a pretty tight product, I'd say. What it does, they're these goggles. So all that comes in the box are the goggles themselves, and they allow you to see things like thrown objects, the exact position equation of them. So it's pretty tight, and they look cool. I would wear them in my free time. Yeah. So yeah, they're pretty tight. All right, we're about to do a quick little review of this product. I got my friend Chunts over here. He's about to throw this ball. It's a pretty tight ball. I'd recommend it. These glasses are pretty tight too. But here we go. Tight.
These goggles pick up the equation.
Bro, I saw it straight in the air. It's crazy. Dude, come check this equation out.
Yeah, put that in the
Yeah,
calculator.
I gotta put it in. I'll put it in Y1, bro. Look at that, bro. Look at that graph. Dude,
Damn.
exact-
What's the equation?
Bro. Look at that equation. It's a beautiful equation. Dude, that's tight.
Bro, did you see how fast I just threw this ball? You should definitely try and figure out how fast I threw it.
Yeah, bro, you had such a good arm. Okay, so what I have to do, we have to find the velocity equation. So of the position equation, I should take the derivative of that. So let me just take the derivative of that real quick. Alright, tight. So the derivative of the position equation was negative x over 2 plus 2. Alright, so what we do to find the initial velocity is I plug in 0, right? So at time equals 0, you were throwing at 2 feet per second, bro. That is pretty tight, bro.
Sweet. So now that you have the velocity equation, could you use it to find when the ball reached its apex?
Yeah, no problem, bro. All we have to do is set the velocity equation equal to 0, and then see what that equals. Oh, okay, let me do that real quick. Okay, so when the velocity equation equals 0, it's at x equals 4. Alright, so before x equals 4, the velocity is increasing. After the velocity is decreasing. So that proves that it is the max. So at x equals 4, it reaches its max.
Whoa. It did not seem like the ball was in the air that long, did it, man?
No, bro. I think it's because you threw it so hard it ripped a hole through the space-time continuum. That's all that makes sense to me.
Makes sense. So at time equals 4, which is the max height of the ball, what was that max height?
Okay, so what we gotta do is put 4 in for time into the position equation. So what we do, let me plug that in real quick. Boop, boop, boop. Max height was at 6 feet. Yeah, that seems about right.
Yeah, that seems more appropriate. Can those goggles find any other equations besides just the position one?
Let me check real quick. Oh yeah, right here it says, just slide the knob next to your right ear to the left 2 spaces, and you can see velocity equations. Oh, let me try that. Oh man, you do not know what I'm experiencing. I am seeing everything in velocities now.
Let's go test it out.
So we're testing the velocity setting on these glasses, and Chance over there is about to throw this ball for us. Alright, Chance.
So what was the velocity equation?
I got negative x over 8 plus 1. That was the velocity.
Tight. So do you think you could use that to find the total distance the ball traveled?
Oh yeah. So what we would have to do is take the integral of the velocity from 0 to 8, and that's where it had a positive velocity.
Makes sense.
Subtract from 8 to 16 where it had the negative velocity, and that will give us the total distance traveled. Let me do that.
What was the total distance traveled?
I got 8.
8? It definitely traveled more than 8 meters.
Yeah, that did not sound right. Let me check the units on this bad boy. Boop, boop, boop. It's in units of 5 meters. So it went 5 meters.
So 40 meters.
Sounds about right. Who made these glasses, bro? That's more than one of my complaints I think about these. 5 meters? Like, why? 5 meters.
We'll get to that in the review section.
Yeah. That'll be
So by integrating the velocity equations that the goggles gave you, how high was the ball at its apex?
Alright. since we already deduced that the apex was at 8 seconds, or whatever units these glasses are using, we take the integral of the velocity equation from 0 to 8. And FTC Part 2 tells us that equals the position at 8 minus position at 0, so we can add position of 0 to the integrated side.
Makes sense.
And since we're going to say you threw it out about 6 feet high, we should take the integral of that. So we can find S of 8 at the apex. And there we go. S of 8 is 10. And that would be in 5 meters.
So 50 meters high.
Yeah, that's a pretty good arm, bro.
Thanks. So after extensive use of this product and all of its functions, how would you rate it?
Well, they're pretty stylish looking glasses, so that's a plus. I do have 2 complaints though.
What are those?
The colors, you only can get in red, and I would like to see more available colors for that. Second complaint is how when you're working in velocity, it gives you units in 5 meters, and that just whacked me. Straight communism right there. But other than that, these are really, really, really great glasses for a guy like me who just loves doing math problems. So out of 10, I'd give this a 9.367 out of 10.
Makes sense. And I like how you rounded to 3 decimal places. Calculus.